Okay, so it's come to my attention that the worksheet number 2, which introduces you to the work on limiting reagents with Ms. Block's worksheet, she's starting out with the formula that you see above in a balanced equation, and you just simply have to do crossover steps to figure out how much moles of sodium hydroxide you actually need. So if you have 4 moles as you're given available of water, then you have to compare that with the 2 moles of sodium hydroxide used and the 1 mole needed for the sulfuric acid, and another result of the 1 mole of sodium sulfate. So you just have to do these calculations. 4 to 1 over 2 gives you 2 moles of sulfur, which would be the same for Na2SO4. Hopefully that's clear enough. The next problem leads you down to basic mass-to-mass problem. This is a basic mass-to-mass problem. What we've been doing with worksheet 1. So 200 grams, go through the process and you'll end up getting 245 grams of H2SO4. Do that over again to solve for the sodium sulfate, except remember the formula mass changes because you're working with sodium sulfate instead, so 355 grams would be your answer. Of course, there's the formula mass calculation that I do on the side when I'm doing these problems. But when you get to letter D, the whole problem changes and you get a limiter problem now. And so you really have to use the balanced equation to be able to know that which one is going to hold the reaction back. So is it going to be the 100 grams of sodium hydroxide, or is it going to be the 150 grams of sulfuric acid? So you have 100 grams converted back to the mole, but now I'm going to do a crossover step related to the 2 reactants. So for every 1 mole of sulfuric acid, I know 2 moles of sodium hydroxide are going to be consumed. So you have to factor that in. So it tells you that you have 1.25 moles of sulfuric acid that you will need to react with that 100 grams. So you have to compare that now with 150 grams of sulfuric acid to how many moles you have available. You have 1.53 moles available to you. You only need 1.25 moles, so therefore the sulfuric acid is the one that's you got plenty of. Therefore it's the excess one. That means by default then the limiter is going to be the 100 grams of sodium hydroxide, because you got more than enough sulfuric acid to make this reaction completely consume 100 grams. So we go now to the next page. If I can get this itemized, I could actually have done this, or I can double check myself. And I'll just let that kind of sit here. You can stop time the video to be able to see the calculations. But the short of it is that I take that 1.53 moles and I compare it to the moles of sodium hydroxide, which tells me that I have 3 moles of sodium hydroxide that I need to react with the 150 grams of sulfuric acid. I only have, from my calculation, from the original calculation, I only have 2.5 available. I need 3, therefore the sodium hydroxide confirmingly is the limiter. So the stoichiometry now is totally dependent on the 100 grams of sodium hydroxide. So the rest of your calculations have to be based on the sodium hydroxide. So let's go to letter E, and you can see then that if you're given 100 grams to start with, and you know it's already the limiter, hopefully I can get this focused. I can just go ahead and start with the 2.5 limiters that I have right away. I can do the 2.5, do the conversion over to sodium sulfate. For every 2 moles, it's a 1:2 ratio. I have 1.25 moles of sodium sulfate that will form. Take that a step further, and I'll move this over here to letter F. How many grams would theoretically form? And remember, a theoretical formation is going to be what the stoichiometry tells you, but not what you will get in a lab, because the lab has plenty of little, procedural errors. You're not going to always get the theoretical value of 175.5 grams of sodium sulfate. 1.25 moles is converted to the 140 over 142 grams of sodium sulfate over 1 mole gives me that I can theoretically produce in this particular experiment 177.5 grams. Now, you're going to get less than that when you actually do it in the lab. So that would be called the actual yield. And our next worksheet will be taking the Stoichiometry, comparing it to the actual yield to give us what's called our percent yield. That's coming next.